Hello everyone and welcome to another episode of Data Drift. And in this video we are going to build a RAG-enabled chatbot using LLamaindex and Jupyter Notebook. Things that we are going to learn today: introduction to RAG-enabled chatbots, overview of LLamaindex, and design and prototyping a RAG-enabled chatbot using LLamaindex and Jupyter Notebooks. So basically we are trying to create a small chatbot interface in Jupyter Notebooks. Now, what is RAG? So, retrieval augmented generation, or RAG, is a technique to retrieve facts from an external source, that is a knowledge base, and modify the generated answer of a model based on these retrieved facts. So here you can see a very small diagrammatic representation of what a RAG system would look like. So ideally you have an interface through which a user interacts, and the user query goes to a RAG engine, and it queries a data source and then augments the knowledge gathered from the data source onto the LLM or large language model, which then forms an answer to your query and displays that to you as or the user in an interface. Now, how do we design our RAG system? So first of all, we have a document loader that reads the document and helps in ingesting that and passes that or stores that onto a database. For us, in this particular example, we will be having a SQL database where the document loader would be storing all the data from a CSV file. Then we are going to create indices on the database. So indices are pointers to different places in the database, which makes the fetching of the data easier and faster. So the searching of the indices is made by the query engine, and then the query engine sends all this data to the large language model, and basically it augments the large language model's knowledge with the knowledge extracted from the database, and finally the large language model would present an output. Now there are certain steps which we are going to follow to build our RAG system or our RAG pipeline. As I explained earlier, that we need to load and read the documents and then store them in SQL table, and then enable a system where the user can input his query, his or her query, and that would be a front end. Now the user query would be turned into embeddings by an embedding model, and then the query engine would query the database and as per the to fetch the context or things related to the user query, and then augment it with a prompt and send it to a LLM, large language model, and then the large language model would finally return an answer. So we will now move on to the actual demonstration of how we are going to build a RAG-enabled simple chatbot in Jupyter Notebook using LlamaIndex. So this is my notebook. We'll go through the steps. And first of all, we need to do certain installations, but you can look into the notebook, that the link to which I will provide in the description section, and you can go through what all things are required. So basically, you require a LlamaIndex, and then LlamaIndex LLM Hugging Face, that is another library, and a few other libraries like SQL Alchemy and Sentence Keys. So this is not important as important as the actual steps that we are going to follow. So we'll skip through it, and we will look at the data that we are going to use. So for this video, for this example, I have taken a data from Kaggle itself. It's known as Goodreads 100K books. It is the data set name. Now in the data set, there are collection of 100K books from the Goodreads website. It has different details about the books, like the name of the book, some excerpt of the book, and the author of the book, the rating, general rating of the book, etc. And what we are going to do is that we are going to download the book and unzip it on our local. And then we are going to use Fast AI, which is a deep learning library which enables it to train deep learning models. But here we are going to use certain convenience functions provided by Fast AI to do certain stuff, right? So let's say, for example, now we have a path where we have stored our data set, but this one, the Fast AI is, the Fast AI is convenience function like path enables us to fetch the path for, files included in a given path. So it is an extension of Python's pathlib module and helps us to do certain stuff. So now I have run the notebook. So as you can see, it will take a while to install our required libraries. So we will wait for it, and then we will proceed on to the other steps. Okay, so now as you can see, we have the file in our path. It is a CSV file, and we will use pandas to read the file. And a couple of rows of data would look like this. We have the author's name here, the book format, description of the book, genre, rating, etc. Now, we would be extracting these data from this CSV and store it in a SQL file. Right. So for this, we are going to use a library known as SQL Alchemy. So SQL Alchemy is a Python library which makes it easier for you to deal with database and tables from your Python code. So what we are going to do is that we will create an engine that will determine that which underlying database engine we are going to use. For us here, we are going to use the SQLite database, and this is our table, which is actually stored in our disk to save memory. And this is our table name. Now we are going to use pandas to SQL function and passes it to convert to take the data from that we have created over here into an SQL database. Now what we're going to do is that we will wrap our SQL database in a SQL database object provided by LLamaindex, right? Um, that would make our SQLite database recognizable by the Llama index library. So this is how we do it. Now the next important thing is to build a table index. The thing is like you cannot directly query a database; it would be slow, and you have to it would take time. So there is no way for Llama index code to actually work on the database directly. So what we are going to do is that we will create indices on the table data on the rows of the table. So these are really like bookmarks to different rows of the table, and that makes it easier for you to or easier for the Llama index code to actually go inside and see, oh, in this particular bookmark some of the required stuffs are there, so let me go directly to that row and fetch my stuff. So that makes things faster. And for that, we are going to use SQL node mapping object provided by uh, LlamaIndex. So what it does is that it will take your SQL database object and it will create nodes or indices out of that. And what we are going to do is that we are going to pass the exact table name from which we are going to fetch stuffs. And I will run it. Now, while building a RAG and using a large language model, our main interest lies here that we are going to we want to build SQL queries to query our database using natural language, and that is done by a large language model. So you feed in a or you give an instruction to a large language model, and the large language model creates an SQL query, which then goes into a particular layer of Llama index framework, which is known as the query engine, and it then executes the SQL query to fetch certain data. LlamaIndex by default uses OpenAI's API, but here we will use a large language model taken directly from Hugging Face. In order to use Hugging Face, LlamaIndex provided an object known as Hugging Face LLM. So you will have to wrap all your parameters inside that. And coming to the model that we're going to use here is known as Pipeable AI. So this is the Pipeable AI is PipSQL model, and this is the model card. So this model has been trained on SQL queries, so it can build SQL queries given a natural text, now a natural language text. The reason I have used SQL, this particular model here, is that I had used Tiny Llama, Llama 2, Mistral, all those models. But what I have found is that if your use case is specific, like in this example, we do want to generate good quality SQL queries. So a model needs to be trained on on the capability of generating SQL queries. Without that, your uh, RAG system, the queries generated by your RAG system is not that much optimal. So whenever you are going to create a particular RAG system for a specific use case, make sure that your model is fine-tuned or trained on that particular use case. For example, here we want SQL queries, good quality SQL queries. So we need a model that is trained to generate SQL queries. And if such a model is not available, then you need to fine-tune the large language model on your own data or on your own use case. Now coming back to our notebook, we are going to pass our tokenizer name, the model's name, and where we want to run it, whether it is in CUDA or you know uh, CPU, and just remember to set a context window so that your context does not grow out of the limit to which your large language model is set. So, say for example, if your large language model's context window or context length is 2000 and you pass in a text which has a context window of, let's say, 4000, it will go out of scope, right? So you have to set the context window here and also save certain memories. And then another important parameter is max new tokens. More the number, more your memory consumption will be. Therefore, I run this and the checkpoints are loaded. And then the other important thing that we are going to use is an embedding model, because this embedding model would be taking your user query and converting those into embeddings. Now, for those of you who are new to this field, embeddings can be thought of as on a very simple level. Embeddings can be thought of as a index to the words in that particular language in which you are typing a query. This is for the large language model to understand the text, because a large language model does not understand natural language text. It understands number. Now, as a model which is trained on a certain language like English, it has a, you can say, a vocabulary of different words of English. So the query that you usually give to a model, uh, the the embeddings really help the model to take the words from your query and match it to its own vocabulary. So embeddings are like indexes that, okay, there is a particular word, so the related word is in my vocabulary in this particular index, and now the large language model would understand that, okay, since this word from the user's query is present in my vocabulary, so the meaning of the words and so on. Right? One more important thing is that once you have your embedding model and the large language model, you use the settings object from LlamaIndex to really set uh, really tell the LlamaIndex library that, okay, use this particular LLM and this particular embedding model form. Okay. So now we are going to create a new object index that can be used to perform various tasks like searching, everything. And object index is the API from LLamaindex that will help you to make that. We are going to pass the table schema that we have created. So let me go up. This is the table schema that we have created here. Now table schema really tells the query engine that okay, these are the columns, these are the column types in the underlying table, and use that. Okay, and then the table node mapping, as I explained earlier, that nodes in the context of llama index are the indices, right? So it really makes a graph structure. Llama index makes a graph structure of all the vectors of your data, or the numerical representation of data, and then while querying it searches through all the nodes or all the indices in your graph structure to find the actual text or corresponding to your query, and we will pass the vector store index, which is a index created within llama index library, and it represents your textual information or the content of your underlying database or your data store. As I said that earlier, that the the searching of the underlying data store or the knowledge base is done by the query engine. Let me go to the diagrammatic representation. It would Okay. So this blue box here is our query engine, which actually does search across the indices and the knowledge graph, and that is what we are going to build here. And since we are going to use a SQL table, our underlying data store is an SQL table. So LlamaIndex provides a SQL table retriever query engine, an object to which you can pass your SQL database object's reference, and you can say that okay, use this particular object as a retriever, its index as the retriever, and return me the top 5 similar queries from there. And let us test it out. So I have a simple query asking the our rack system that which title has the highest rating. Okay, so it is doing some searching over that, over our data, and here it is. Okay, the title with the highest rating is R101, a pictorial history. Let us try, and yeah, it would also you know show you all the SQL queries that it has created, right? And as you can see, that it has created the SQL query all by itself. We just provided it with a natural language description of what we want, and it created a good enough SQL query, right? And this is the actual SQL query that it was using. And as you can see, the SQL query is, good, like a human would design the SQL query. It is cool to know that large language models are so capable that they can design a SQL query by themselves. Let us try another query. I will ask the RAG system that who is the author of this particular book, and let me run this cell here, and here is the result. Here is the author's name for this book, and here is the SQL query that our large language model has generated. Okay. Uh, Now there is one more layer of testing that we will do. What we will do is that we run an SQL query here. We will take the same SQL query generated by our large language model and run it, and see, it has given us the title of the book with the highest rating, which matches with the result generated by our large language model. Now for the second question, that who was the author of this particular book, we'll run another SQL query, and this is the author's name, which again is matching with the result that our RAG system has given. So this is good. So now we know from our testing that for our use cases or for our queries, the RAG system is giving us correct answers. Let us go ahead and build a simple GUI or graphic user interface. Now, why this is important is because you might be an architect or you might be a data scientist out there in your team, and you need to show your team or your customer that this is what a interface would look like, and this is what you know you want to give an idea that this is how your rack system behaves. So we will create a simple GUI or a search box using IPY widgets to create graphical user interface components in Jupyter Notebook itself. The code here is not important, but this is what it is. So I had run this, and this is my text box. So let me type in a query which title as the highest rating, and let me run this query. Now my chatbot will start searching my database, and it will give me a give me an answer. Right? So in a real world use case, you can modify, you can create a beautiful front end, modify the U chatbot response and all those stuff. But for this video, this is enough. We just want to showcase or showcase a prototype of a search box or a search system or a chatbot which you can ask questions and it would retrieve the answers based on your own data. Right? So this was all for today's video, and next videos we will further explore how we can improve our chatbot, track enable chatbot, and what are the different concepts over there and how to create some advanced systems. Till then, thank you, and do subscribe to my channel, like it and share it so that others can discover my content easily.